All right, good afternoon. We're going to run through a couple other sets of problems here that will just continue the idea that we talked about yesterday with starting with the quadrilateral and then being able to determine, yes or no, whether you can end up with a parallelogram. So start with a quadrilateral, 4 sides. Do we know for sure, can we figure out that it is a parallelogram? Okay? All right. So I'm going to start you off with a group of 5 problems here. And the directions are going to be this. Decide whether the given that I give you in each example is enough information to determine if a quadrilateral is a parallelogram. So the first example, if I tell you one pair of opposite sides are parallel, is that enough information to determine whether the quadrilateral is a parallelogram? Okay, so to make the call, we either need to figure out that the quadrilateral meets the definition of a parallelogram. Remember that from a couple of days ago. Parallelogram is a quadrilateral with 2 pairs of parallel sides. Or it meets one of the 4 theorems that we talked about yesterday. 8.7, opposite sides are equal. 8.8, opposite angles are equal. 8.9, one pair of opposite sides are both equal and parallel, or the diagonals bisect each other, 8.10. Okay? So that's the idea. So, excuse me. And so what I'm going to be asking for is first a yes or no. Can you guys decide whether you can make the call on a parallelogram, yes or no, with what's given? If no, we're done. If yes, which theorem are we going to be using? Okay? So first example, easy one. If I tell you that one pair of opposite sides are parallel, one pair of opposite sides are parallel, is that enough information to determine if it's a parallelogram? No, that's not enough. Using the definition, we'd have to know that both pairs, 2 pairs of opposite sides are parallel, all right? And we don't. We're only given one pair of opposite sides are parallel, so that's going to be a no. And it's real easy to give you a kind of a counter example. Later this chapter, we're going to look at a shape called a trapezoid. And in a trapezoid, actually by definition, the way it's set up, a trapezoid is going to be a quadrilateral with exactly one pair of parallel sides. And that would fit the given, but obviously not going to be a parallelogram. Okay, my second example, also a very easy one. What if I give you that the diagonals bisect each other? That's simple, all right? That's a simple one. That's an easy yes, because that fits exactly, I mean, it's not even tough. That fits exactly theorem 8.10. That's exactly what theorem 8.10 says. Easy. Okay? Try some more. What if I tell you that all 4 sides of a quadrilateral are equal? Now that doesn't fit any of the theorems exactly, but if all 4 sides are equal, all right, if all 4 sides are equal, does that force it to be a parallelogram? Well, I could draw you a couple pictures to help out. I could draw you a quadrilateral like that, where all 4 sides are equal, or I could draw you a quadrilateral more like that. But again, the idea would be all 4 sides are the same. Now, if all four sides are equal, does that force it to be a parallelogram? Well, using theorem 8.7 as an example, would the opposite sides in this direction be equal? Yes. And would the opposite sides in this direction be yes? So are opposite sides equal? Yeah. I mean, they're all equal to each other, but for sure the opposite sides are equal. And on this other picture, the same thing. Opposite sides equal? Yep. Opposite sides equal? Yep. So anytime we know all 4 sides are equal, the thing's going to be a parallelogram. And in this case, we're using theorem 8.7. Okay. How about the next one? How about when diagonals are equal? How about when diagonals are equal? Well, obviously we have a theorem that talks about diagonals, but the theorem says, like our second example up above, That says that a quadrilateral is a parallelogram if the diagonals bisect each other. It doesn't say anything about equal. So since this one doesn't quite match up, this one's going to be a no. And if you're interested, I again could give you a pretty easy picture of something that's obviously not a parallelogram, but if I sketched in the diagonals, the diagonals actually would be equal to each other, right? The diagonals can be equal without the shape being a parallelogram. Okay? And I've got one last one. What if I give you a quadrilateral where all four angles are equal? All four angles, oops, sorry, I didn't say mean equal. I meant to say all four angles are right angles. Okay? And again, I'll just try to help out a little bit with a picture or two. What if I gave you a picture like this, and all of the angles were right angles? Would that thing have to be a parallelogram? Well, using theorem 8.8, if they're all right angles, question, would these opposite angles be equal? Sure. And would these opposite angles be equal? Sure. So even though they're all right angles, opposite angles are equal. So we would say yes, and we'd be using theorem 8.8. Okay, so that's the first type of problem I want to go through today, is just being able to give you guys some info, and you'll see this in your assignment, or maybe you already did, but give you some information, and can you make the information fit either the definition of a parallelogram or one of the theorems to prove a quadrilateral is a parallelogram. Okay? All right. Then the next type of problem we're going to do is we're going to give you guys the vertices for a quadrilateral. So here's this next one. And so what we'd have is 4 points that make up a quadrilateral. So A, -4, 7, B, 3, 0, C, 2, -5, D, -5, 2. And the question is going to be, would those 4 vertices and the quadrilateral formed be a parallelogram? Okay? So of course what's required then, what's required is a graph, a picture. We need to sketch out this thing to see what it looks like. I've got a little bit of graph paper here, I think, pasted. And I'm just going to try and shrink that up a titch so I'm not wasting all of the room. In fact, I could scooch it over here. There we go. That doesn't look too bad. And then what I could do is locate those 4 points. So A, 4 to the left, up 7. So I'm just doing the best I can. 4, 7 I think is right there. B is 3 to the right. Then don't go up or down. C is 2 to the right and 5 down. And D is 5 to the left and 2 up. Okay, so let's see. I'm just going to double check that I did that okay. 5 to the left and 2 up. 4 to the left and 7 up. 1, 2, 3, 4, 5, 6, 7. I did okay there. 3 to the right, 2 to the right, and 5 down. Geez, I think I did okay. So I'm going to do a connect the dot puzzle. So I'm going to connect all of those points. And now that I know where they're located, A, B, C, and D. So would that be a parallelogram, yes or no? Well, to prove it's a parallelogram, we'd need to use one of the theorems or the definition. Okay? Again, the definition, 2 pairs of parallel sides, or one of the theorems, opposite sides are equal, opposite angles are equal, 1 pair of opposite sides are both equal and parallel, or the diagonals bisect each other. Now, a couple of those are difficult. Theorem 8.8 would be difficult to use because what that would force us to do is calculate the angles at all 4 vertices. And that's tougher than you think. Right? That's tougher than you think. We either need to use some pretty advanced trigonometry or we need to use some vectors, and both of those are tough to work with. So we'll save that idea for next year. Okay? The other one that's going to be tough is the diagonals bisecting each other. Of course, we could draw in the diagonals from A to C, from B to D, but then we'd have to figure out if they actually bisect each other, and that's a lot of work. So I think the three decent options are the definition, opposite sides are equal, or one pair of opposite sides are both equal and parallel. Okay? And I'm going to do two examples like this, so I'm going to do it in two different ways. As an example, on this first one, what I'm going to do is I'm going to use the definition. Oh, and I can switch back to white so this shows up a little bit better. Okay, I'm going to actually use the definition. And the definition, again, was two pairs of parallel sides. Now, to use that definition, what I would then need is the slope for all four sides of this quadrilateral. I need the slope of AB, the slope of BC, the slope of CD, and the slope of D back to A. All right? And if you don't remember, the slope formula is the difference of the y's divided by the difference of the x's. And I'm not going to write that down every single time, just this first one. That's the slope formula again. So the slope between A and B is the difference of the y's, 0 minus 7, and the difference of the x's, 3 minus a negative 4. So what I end up with is negative 7 over 7, which is negative 1. All right, then the slope of BC, would be the difference of the y's, 5 minus 0, and the difference of the x's, 2 minus 3. 5 minus 0 is 5, 2 minus 3 is negative 1, and 5 divided by negative 1 is negative 5. All right, then the slope of CD, difference of the y's, 2 minus a negative 5. Difference of the x's, negative 5 minus 2. 2 minus a negative 5 is 7. Negative 5 minus 2 is negative 7. And 7 divided by negative 7 is negative 1. And finally, the slope of DA, that's just a little tougher for my eye to catch. The difference of the y's would be 2 minus 7. And the difference of the x's, negative 5 minus a negative 4. 2 minus 7 is negative 5. Negative 5 minus a negative 4 is negative 1. Boy, did I screw something up there? Oh my goodness, what am I doing there? Negative 5 minus, so I've got positive 5. Let's see. I'm just curious if I screwed something up. Oh, for goodness gracious. I did make a mistake. I thought the correct answer on this was yes, it is a parallelogram, but what I got for work right now would say no. Let me show you what I mean. For this to be a parallelogram, opposite sides would have to be parallel to each other. So AB and CD would have to be parallel to each other. And if they're parallel to each other, their slopes have to be equal. And you can see the slope of AB and the slope of CD are equal. Therefore, we would know that AB is parallel to CD. But I have an error because when I looked at side BC and side DA, the slopes were not the same. One slope was negative 5 and the other slope was positive 5. And those aren't obviously equal. So I was wondering if I had a mistake, and I do. What I forgot to do was I forgot to drop down this negative on the 5. I forgot to drop down that negative on the 5. So it should have been negative 5 minus 0. And negative 5 divided by negative 1 would have been positive 5. And then when you see that these values are the same, that means then that BC and AD are parallel to each other. So using the definition of a parallelogram, all right, that opposite sides are equal, we can see then that the quadrilateral is a parallelogram. Okay? And I've got one more of those for you. Hopefully I'll try not to screw this one up. I've got one more of those problems for you. Okay? If you're a note taker, maybe you don't need to put down both of them, but you could just watch, follow along with this one. Okay, so again, giving you the points for a quadrilateral. So I'm going to give you P, -2, 8, Q, 2, 7, R, 5, 1, and S, 1, 2. Question, would those points make up a parallelogram? Again, I'll give you a little bit of graph paper to work with. And I'll again try to shrink that up so I don't use up too much of our space. Okay, there we go. Again, I'll switch to red so hopefully it sticks out a little bit. So P is 2 to the left and 8 up. That's right about there. Q is 2 to the right and 7 up. R is 5 to the right and 1 up. And S is 1 to the right and 2 up. Again, if I do a connect the dot puzzle to create the quadrilateral, I would then have P, Q, R, and S. All right? And again, is that a parallelogram? Okay. Now, instead of using the definition again like I did on the previous problem, this time I'm just going to choose one of the other theorems. And the theorem I'm going to choose this time is I'm going to use theorem 8.9. And what that one says is if one pair of opposite sides are both equal and parallel. One pair of opposite sides are both equal and parallel. Okay? And just for the heck of it, I'm going to choose opposite sides PS and QR. So I just tried to make those a little heavier so they kind of stick out on the picture. PS and QR. Okay? I want to show you guys that they're both equal and parallel, or we'll ask, I should say. Not I won't show you, I'll ask, are they both equal and parallel? Okay? For the parallel, we can use the exact same idea that we just used on the previous problem, so let's get that going. Let's find the slope of PS, and let's find the slope of QR. Okay, again, difference of the y's, difference of the x's. For PS, the difference of the y's would be 8 minus 2, and the difference of the x's would be -2 minus 1. Okay, this time I'm going to double check so I don't make a mistake. 8 minus 2, -2 minus 1. Yep, I did okay. So 8 minus 2 is 6, -2 minus 1 is -3, and 6 divided by -3 is -2. Then for QR, difference of the y's, 7 minus 1, difference of the x's, 2 minus 5. 7 minus 1 is 6, 2 minus 5 is -3, and 6 divided by -3 is -2. Since the slopes turned out to be equal, that therefore tells you that PS and QR are parallel to each other. Okay? Then, using theorem 8.9, I would also need to know that the length of PS and the length of QR are equal. And to make that calculation, what we're going to do is use the distance formula. All right, so to apply the distance formula, the length of PS is then going to be the square root of the difference of the y's, 8 minus 2 squared, plus the difference of the x's, -2 minus 1 squared. Right, and you kind of see the same arithmetic directly above. 8 minus 2, the difference of the y's, -2 minus 1, difference of the x's. So you can kind of help yourself out a little bit. 8 minus 2 is 6. -2 minus 1 is -3. -6 squared is 36. -3 squared is 9. 36 plus 9 is 45. Now, instead of worrying about reducing that, which I know everybody could do, I'm just going to leave it as that. Okay? And then find the length of QR in pretty much the same fashion. Distance formula. So the difference of the y's squared plus the difference of the x's squared. 7 minus 1 is 6. 2 minus 5 is -3. Let me just scooch up a little bit. I just need one more little line. 6 squared is 36, negative 3 squared is 9, and 36 plus 9 is 45. We can see the two distances are equal. Therefore, we know that PS is equal to QR. So we have one pair of opposite sides that are both parallel and equal. So we've shown using theorem 8.9 that the quadrilateral is a parallelogram. All right, it is a parallelogram. Okay? And I've got one last problem I'd like to do with everybody, and then we'll call it a week. Okay? So one last problem, and this time it's going to be the same sort of problem. I'm going to give you ordered pairs, but I'm not going to give you all 4. What I'm going to ask you to do instead is find the coordinates of the 4th point, which makes the quadrilateral a parallelogram. Okay, and the first 3 points are L, 4, negative 1, M, negative 4, 1, N, 0, 8, and what I forgot the letter. And then what I'm looking for, guys, is, my screen's jumping around on me. What I'm looking for is point O. And I'm just gonna highlight that in red. So what we're looking for is the coordinates of the 4th point that would make the quadrilateral a parallelogram. Okay, what would that 4th point have to be? All right, so as you're jotting that down, I'm going to shrink it up slightly because I'm going to need a little room to work. And I'm going to, again, get us a piece of graph paper to work with. And, I forgot to select it. There we go. And I'm going to try not to, in fact, I'm going to make it as big as I can. There we go. I think that's going to be okay. And again, I'll switch to red so that the points stick out as well as I can. L is 4 to the right and 1 down. M is 4 to the left and 1 up. N is stay in the middle, go up 8. And let me just attach the letters so everybody knows what I'm up to. L to M to N. And if I do a little connect the dot puzzle, connect L to M, M to N, right? What I'm asking is, where does O have to be? Where does O have to fall so that the quadrilateral is a parallelogram? Okay? And if I pick my little arrow here, I hope you guys can see that okay. Where exactly does O have to fall? It feels like it has to be up here somewhere. But where would O have to fall so that the quadrilateral is a parallelogram? And again, we have all kinds of options. Because we have a definition and we have 4 theorems that would help us get that job done. Okay? But I think probably the easiest is to use the definition. I think that'd probably be the easiest. That parallelogram is a quadrilateral with 2 pairs of parallel sides. Okay? So watch what happens, excuse me, watch what happens, guys, if I find the slope of MN, right? We have side MN in our picture, so I could find its slope. So difference of the y's, 8 minus 1, divided by the difference of the x's, 0 minus a negative 4. So what we end up with is 7 over 4. Everybody okay there? Difference of the y's divided by the difference of the x's. So for this quadrilateral to be a parallelogram, the opposite side would have to have a slope of 7/4. Okay? So L to O, wherever the heck O is, L to O would have to have a slope of 7/4. So watch what happens if I go to the picture. I'm going to choose a different color so you don't get mixed up. What if I start at L and go up 7? 1, 2, 3, 4, 5, 6, 7. And what if I run 4? 1, 2, 3, 4. So I've gone up 7 and over 4. I would be at, switching back to red now, I'd be at this point. And I think everybody can then see that if O is supposed to fall there, that MN and LO would be parallel to each other because they have the same slope. But what we better check is now when I complete the fourth side, N to O, that line would also be parallel to the opposite side, LM. So to show you that, I want to find the slope of LM, difference of the y's divided by the difference of the x's. So here we go, LM. So difference of the y's, 1 minus a negative 1. And the difference of the x's, negative 4 minus 4. And so what we get is 2 over negative 8. And of course, normally I would reduce that. But I'm purposely not going to this time. Purposely not going to reduce that this time. Okay? Again, I'm going to switch colors so you don't get mixed up with the red shape. Now what I'm going to do from one of those points is rise 2 and then run negative 8. So what happens if I start at O and I go up 2? So if I go up 2, I rise 2. And then I go left because it's negative 8. 1, 2, 3, 4, 5, 6, 7, 8. I land right on N. In other words, that slope gets me from O back to N. And we've then shown the point that would make this a parallelogram. And that point would be O is located 8 to the right, so the x value would be 8. And how far up is that there, guys? 1, 2, 3, 4, 5, 6. So it'd be up 6. So the ordered pair that would force this thing to be a parallelogram would be the ordered pair, the point 8, 6. Okay? Alrighty. So that's the last problem I'm going to do in this section. And I know I gave you quite a bit of time to work yesterday. So you've got the rest of the hour now to work on the assignment for 8.3. That one's going to be due on Monday. I'm hoping all the schedules are working out, hoping all the technology's working out. I'll be back on Monday, I hope, and then we'll be able to move forward. We'll do a bunch of questions, and then we'll move forward on 8.4. Okay? All right, so hoping all this is working out, and if it is, this is Friday, so you should hopefully have a great weekend, and we'll see you on Monday. See you later.